are you?
I, I'm good, Albert. Thanks. Fated.
Good, man.
Thanks for joining, everyone. And we'll be talking about synthetic data for retrieval augmented generation evaluation. So, first thing, who am I? I'm Shahul. I'm the co-founder of Exploring Gradients, where we build an evaluation framework for retrieval augmented generation. I'm an ML research engineer by profession and also a Kaggle GrandMaster. And one of the four also open assistant in it. So let's dive in. So let's first address the issue of why synthetic data. So in traditional ways, manual and occasional curation of samples have always been very time consuming and expensive. And given that the emerging abilities of LLMs such as GPT-4 to produce high quality human labeled data, this process can be further improved in efficiency to produce synthetic data instead of manual annotation. Also, there is an issue of cold start problem when evaluating and testing LLM pipelines where where there is initial data to evaluate, and the LLMs can be very effectively used to create data and then use it for evaluation. So the third issue is that by training a test set against issues like data rate, that there is a continuous flow of documents into your pipeline can be hectic and also very expensive. So let's dive in and see some of the recent works in creating synthetic data. So the first one and one of the most impressive papers in this domain is Exospect recreates synthetic data, mainly instruction output pairs from a set of documents, also ensuring a certain level of deduplication. And the second one, which is also the most recent one, is Evolve Instruct, which is the method used by the wizard ML to produce high quality synthetic data for fine-tuning and training. So they also have an Evolve mechanism, as you can see here, which ensures a high quality data set with diverse samples. So let's dive in and see look about generating synthetic data based on documents. So this can be done using a very new approach where you have a set of documents and you feed those set of documents into an LLM to generate a question and answer. So this is very simple, but it's a native approach where there are a lot of pitfalls, which will be in the next slide. So I will discuss some of the challenges of this approach here. So LLMs, tend to follow a common path while generating data or tokens. So whether if you gain a particular chunk of text and ask LLM to generate question and answer from it, it is most likely that it has a repeated pattern of generating questions and answers, which will lead to very less diverse set of instruction. There is also a lack of control in the resulting data distribution here because the data generated types of questions and answers are generated is solely based on the LLM's capability, and instant control cannot be controlled by the user. Also, ensuring factuality of generations is important here because LLMs can hallucinate even though the answer is grounded on the given text. There can be some statements that cannot be backed up by the given context. So ensuring factuality in such generations is also important. So here we are working on an Evolve method or generating test data or generating any data from a set of documents. So the main idea here is to generate a truly diverse set of instructions from a given set of documents. And these set of instructions should also follow specific data distribution, which can be controlled by the user. For example, if we see data that can be generated from a set of documents, there can be different type of instructions. For example, there can be instructions which involve a complex reasoning. There can be instructions which involve a complex citation operation, or instructions that involve multiple contexts that requires multiple contexts to answer correctly. There is also an issue of validating the given document. So every document or every child cannot produce high quality data because the information quality of question is highly dependent on the quality of the underlying document. So there is also a need of validating the given chunk of text or document to ensure that it can produce a high quality data. Once that is done, a seed question can be generated from the given document, which can be further evolved using any type of question into any type of question, like reasoning, conditioning, or multi-context. After this process, the document and the source document and the generated answer is compared against to ensure that the given answer, the generated answer for the given question is well grounded in the given text. So you can check out the code and further documentations in the link that is shown here. So users of this pattern, this can be very effectively used to generate a set of question samples or data sets that can be used to fine tune LLMs for array retrieval generation or for general purpose use case. And then it can be also used for prompt optimization and approximation in retrieval content generation pipelines, where there can be multiple components to optimize. For example, in a retrieval content generation pipeline, you may have two components, which is retriever and a generator. Optimizing these without a proper evaluation framework can be very hectic and okay. So, and moreover, this can be used to form a continuous evaluation and testing of your real application by adding this into your framework and generating questions from the string set of documents to ensure high quality performance of your pipeline. This set of synthetic data generation can also reduce the developer time in aggregating data by value percentage in evaluation, because only 10% of time will be spent on ensuring the quality of generating data, and since the data is already generated by the LLM. So that's it, folks. If you have any questions, you can reach out to me on Twitter. Here is my username and DM so far.
Awesome, Shahul. Thank you very much. And people might be able to find you on Slack as well. I already saw a few questions come in through Gradual. It's crazy to think that just like a couple of years ago, people were talking about, just like labeling and coming up with training data and then evaluation. This was like the biggest hurdle, right? And you had just like massive startups found just to solve this problem. It's not a surprise that as soon as we got LLMs on our hands, like the first thing we should do is come up with some evaluation data to help test other models, and now to start to help test themselves. So
exactly,
great to see all that.
I will share the link to the slide in the Slack. And completely agree on the point. I think in future, LLMs will be able to train and evaluate other things.
Awesome. Shahul, thank you very much for joining us.